So, the first chapter that I'll be going through with you is actually called physical quantities. So, physical quantities is actually the first chapter that you will encounter when you're in secondary three. And so, for those who are currently secondary two and going to become secondary three, it is really good for you to guys have a head start. And if you are a sec four that's looking at this video, definitely it is good revision. So first of all, you have to know that physical quantities in general, they are basically properties of an object that can be measured with a measuring instrument. So this definition is actually quite crucial because I've seen it multiple times in your O-level TYS. The important point for this, right, is that it can be measured using a measuring instrument. So for example, length is a physical quantity because you can measure length using a ruler, for example. Always remember your measurement, they consist of two things. The first thing is actually your magnitude, and the second thing is your unit. So magnitude is basically the number, and your unit obviously is your SI unit. So what is an SI unit and why do scientists use them? So a SI unit is basically a standard unit that all scientists around the world will use when they're writing their reports. So I'm sure you guys know that in the US, you got random stuff like foot, yards, etc., which is used to measure length. And in China, you have jin or pounds, which is to use to measure your mass. So if each scientist use a different form of measurement in their reports that is unique to their own countries, this will mess up the whole system. So the SI units is actually introduced so that all scientists, no matter which country they are from, will use a standardized unit system so that people will be able to identify what quantity you're actually talking about. So here are some physical quantities and unit symbols that you must know. So this over here are called the five base units. So I'll go through in depth why they're called five base units in a further lecture in the future. But first of all, you have to know that the five physical quantities that are present is basically your mass, your temperature, your length, your current, and your time. And your SI symbol or unit symbol is actually kg, Kelvin, meter, ampere, and seconds. Take note, your mass is the only one with a prefix. So I'll go through further later on what prefix means, but just notice that over here, your mass is the only one that has two respective units over here, K and G. Okay, so these are over here called base units. So base units definition is basically a unit without a prefix. So I'll further elaborate on what a prefix means. A prefix is basically something that you put in front of a unit. So let's look at an example. So length over here, the unit symbol is meters, but what about centimeters? If you put cm, m over here actually represents your unit, and c, which represents centi, is actually what is known as your prefix. So a base unit is a unit without a prefix. And then you might be asking me, but mass over here, mass has K. Doesn't K represent for kilogram? The answer is correct. Mass is the only exception to this rule. So mass, the SI unit, will be kilograms and not grams. Always remember this, mass is the only exception. Okay, so let's go on further. So here are some common prefixes that you must know. So obviously we are very familiar with kilo. Kilo is 10 power 3. Mega we are not familiar, but you have to know is 10 power 6. And giga over here is 10 power 9. So if I say I have 1 megabyte basically means that I have 10 to the power of 6 or 1 million bytes. The same can be said for 1 megameter. Is basically 10 to the power of 6 meters. So prefixes are extremely useful because instead of writing out so many zeros, what we can do, right, is to actually just substitute it for mega over here. Okay, so now let's go to the slightly confusing part. The slightly confusing part is over here. Your deci, your centi, your milli, micro, and nano. So I'll go through them one by one. There's actually a very easy way for you guys to remember what the factors are. Take note, factor is basically your 10 power something. So let's write down all the prefixes first. So you have your giga, you have your mega, you have your kilo, you have your deci, you have your centi, you have your milli, you have your micro, and you have nano. So the first thing that you will have to do, right, is to actually memorize the sequence from the largest to the smallest. Giga, mega, kilo, deci, centi, milli, micro, and nano. Then the second step you want to do is to actually memorize the factors. And the factors are actually quite simple to memorize for the first few. So giga, always remember you start with 10 power 9. And then for every one that you go down, for example, the next one is mega, you will have to deduct the power by 3. So mega will be 10 power 6, kilo will be 10 power 3. So far so good. Now comes the slight tweak. So your deci, always remember, starts with 10 power negative 1. So deci is 10 power negative 1, centi is 10 power negative 2, milli is 10 power negative 3, micro in this situation again is minus 3, so it will be 10 power minus 6, and nano will again be power minus 3, which is 10 power minus 9. So just remember for the first three terms over here, it is minus 3. Then for the next three terms, it starts with minus 1 over here, and each term you move down will be an additional minus 1. And then the last terms over here will again follow the rule of minus 3. So basically, just remember for this one, you have to remember the direction which is of descending order, which is giga, mega, kilo, deci, centi, milli, micro, nano. And also remember the factors and what each represents. Okay, so now we go to the fun part. Conversion between a base unit and a unit with prefixes. So this one is extremely important and it's actually quite simple to understand. So remember your base units are basically units that do not have prefixes. So for example, it's your meter, and your unit with prefixes will be obviously something like cm, where C represents centi. Remember your deci, centi, milli, micro, nano, all of this, they're actually prefixes. And over here is what is known as a factor. Factor is 10 power something. So in general, if you want to convert a base unit into a unit with prefix, you will have to divide the factor, which is divide this number here. And if you want to convert your unit with a prefix to a base unit, you will actually have to times the factor. So let's look at an example question over here. If I want to convert 0.05 meters into nanometers, what do I have to do? So the first thing we have to identify is 0.05 meters over here is actually my base unit. And nanometers over here is actually my unit with prefixes. So this question is basically asking me to convert a base unit into a unit with prefix. And based on this, which you should memorize, base unit to unit with prefix, you will have to divide by the factor. So let's look at this. This is nano. So for nano, it is actually 10 power minus 9. So to convert your base unit into a unit with prefix, we actually have to divide by 10 power minus 9 in this scenario. And if we do that, we actually get this value here. So this means that 0.05 meters is actually equivalent to 5 times 10 to the power of 7 nanometers. So for you guys that actually don't know what a factor means, 10 power 3 basically means is 1 with 3 zeros. So the same can be said with 10 power 6. 10 power 6 is basically 1 with 6 zeros. I hope that makes that clear. Okay, so next, let's move on to this example over here. So again, the other thing that we will have to take note of is actually what is represented by each of the prefixes. So take note that your micro is actually quite special. It's actually an inverted U over here. The rest, I mean, you can guess. You look at small m is milli, centi starts with a C, deci starts with a D, nano starts with an M. So most of them are intuitive except for your micrometer. So first, let's identify what are they asking us to convert into. So first of all, they gave us something that is with a prefix, and they're asking us to convert it into your base units. So the first thing you have to identify is that this question is basically asking us to convert from a prefix into a base unit. So when you're converting prefix into base unit, you must always remember that you will have to times the factor. From a prefix to a base unit, you will have to times a factor. So what factor should we use? Do we use 10 power 3, 10 power 6, 10 power negative 6, 10 power negative 2? What we have to look at is this over here. What is the prefix that's being used? So the prefix that's being used is micro, and it should be already in your head. Your micro will be 10 power minus 6. So to convert 6.85 micrometers into meters, what we want to do is to simply take 6.85 and we multiply it by the factor of micrometer, which is 10 power minus 6. And doing that, we will actually get the answer over here, 6.85 times 10 to the power of minus 6 meters. Okay, so what example 3? Try to pause the video and try doing it yourself first, and I'll get back to you soon. Okay, so now 25.4 millimeter to km. So this question is actually quite interesting. So what this question is asking you to do is to actually convert a prefix into another prefix. So how would you want to do this question? So this question actually requires an additional step. So the first thing you will want to do, right, is to actually convert your prefix into your base first. You want to convert it into your base unit, and then you want to convert your base unit into a new prefix. So the prefix that we are starting with is milli, and if you have remembered the table shown above just now, your milli has a factor that is 10 power minus 3. Okay, so now we will have to recall what is the base. So the base, obviously, in this situation is just meter. And if we are converting from a prefix into a base, do we multiply or do we divide? We will actually have to multiply. So in this situation, we want to multiply by the factor. And since the prefix that is given over here is milli, the factor that we want to multiply by it is actually 10 power minus 3. Okay, then next, we want to convert the base to a prefix. So again, you have to memorize this. From conversion of a base to a prefix, you actually want to divide by the factor. So obviously it's divide, and then let's look at the factor. In this situation, we are converting it into kilo. And if you have memorized it, kilo, the factor is actually 10 power 3. So you have to divide it by 10 power 3. So in this situation, to convert from mm to km, we have to first times 10 power negative 3, and then we will have to divide by 10 power 3. So the answer for this question is simply 25.4 times 10 to the power of minus 3 divided by 10 to the power of 3. And as you can see from the answer over here, your answer will simply be 2.54 times 10 to the power of negative 5 kilometer. So for this question, it's slightly harder because they're asking us to convert from a prefix into another prefix. And by doing so, we actually have to first convert the prefix into a base and then convert the base into another prefix. So this question type is actually quite challenging. And if you guys still don't get it, you can just DM me any questions that you have. Okay, so now let's look at example 4 over here. So over here, the question told us that the thickness of the textbook is 2.6 cm and it contains 500 sheets of paper. And they're asking us what is the thickness of one sheet of the paper. And take note over here, they want us to convert it into meters. So first of all, if you know that 2.6 cm is 500 sheets of paper, this is actually quite simple. What you can do is to actually find out what one sheet of paper is in terms of cm. It is basically 2.6 divided by 500. And the next step we want to do is to actually represent it in the form of meters. So we're actually converting, in this situation, a prefix into a base, which is your meters. And the prefix that we have is actually our cm. So you have to think to yourself, from a prefix to a base, do we times or do we divide by the factor? And if you have memorized it correctly, it should be times the factor. And we have to determine what the factor is. In this situation, the prefix is centi. And if you have memorized the table above, emphasis on memorizing it, centi will actually be 10 power minus 2. So if you know that centimeters is 10 power negative 2, to convert your prefix into a base, you have to multiply by 10 power negative 2. And multiplying this will actually give us the final value of 5.2 times 10 to the power of negative 5. Okay, so far so good. Okay, for work example 5, I want you guys to just try, pause the video currently, and once you guys are done, this is actually the answer over here. So to solve the question, what you want to do is to actually convert each of the numbers that he gave you into a common base unit. So when you convert all of them into a base unit, then you are able to actually compare which one is the largest and which one is the smallest. Okay, so now let's continue moving on. So now we are actually going to move into the more important part of your question, of this topic. So first of all, you will have to know what is the difference between a scalar quantity and a vector quantity. So for those who are actually incoming Sec 3s, who just finished their Sec 2s, this is actually a new concept that you will have to know, but fret not, it's actually quite simple to understand. So first of all, your scalar quantity is basically something that has magnitude only. Okay, so keyword is only magnitude. Your vector quantity is basically something that has both magnitude as well as direction. So magnitude and direction. So how do we know if something has direction or not? Let me give you a perfectly good example. Time. Do I say, oh, time is moving to the right, time is moving to the left? Time is moving up, time is moving down. Okay, so technically, I know you guys have a countdown, so where the time is actually decreasing, but time in general, they do not have a direction. You cannot say that time is going to right, time is going to the left. So time obviously has a magnitude because there's a number involved. So time is actually a scalar quantity. So take note, the difference between scalar quantity and vector quantity is that your vector quantity actually has a direction. So an example of this, right, would be here. So your velocity, acceleration, displacement, force, and weight, all of them are vector quantities. So let's explain why. Velocity vs speed. So this is a concept that we will actually go through in the second topic, which is kinematics, but I'll just give you a brief run through first. Your speed, I'm sure you guys learned in Sec 2, is basically your distance divided by your time. Velocity is actually displacement divided by time. So this, for those who are Sec 2s this year, don't care about it yet. I'll go through them in the next topic. But for those who are Sec 4s, you guys, who are Sec 4s next year, you guys should know this by now. Okay, let's look at one that's more easy to understand, which is your acceleration. So when I say something is accelerating, even though Sec 2s, you haven't learned what acceleration means, you can actually derive that acceleration basically means that you are speeding up. So when you're speeding up, it means you are going faster. What is the opposite of acceleration? You guys should know, even though you've never learned, is basically your deceleration. So what is deceleration? Deceleration basically means slow down. So let's imagine we have something that's moving to the right. When I am accelerating, it means that I'm moving faster to the right. If I'm decelerating, it means that I'm slowing down to the right. So as you can see, acceleration actually has a direction. And if the quantity has a direction, it means that it is a vector quantity. Okay, so let's look at some examples. So over here, let's try some questions. So first of all, explain what is meant by a physical quantity. So just remember the definition for physical quantity is basically anything that that is able to be measured using a measuring instrument. So for example, your volume, it can be measured using a volumetric flask or a beaker. So this is the definition. Can be measured using a measuring device. Okay, so I won't be focusing on these questions. I'll just be focusing on theory and state. So the next thing we will have to do is to actually know how to measure our length. And the first thing before measuring length, we have to know that the definition for length is the distance between 2 points. And the SI unit for length is actually meters. Take note. So in the laboratory instrument that we can use to measure length, there's multiple. We have our measuring tape, meter ruler, vernier caliper. Micrometer is currently not in your syllabus. External and internal caliper is. Okay, so let's look at our measuring tape and measuring ruler. So take note, though both instruments will have an accuracy of 0.1 cm. So a good question will be this. What is the difference between accurate and precise? So the easiest way to actually show this is actually through archery. So let's imagine we have a target over here, and then our bullseye is over here. Then we have points, which is our arrows that is somewhere here. We can say that this is actually accurate. And the reason why this is accurate, the definition is basically it is close to the true value, which is represented by the cross over here, which is a bullseye. Precise, on the other hand, actually basically states that the data points are close together. So an object can actually be precise but not accurate. An example of that would be this. So precise basically means the data points are close to one another, as you can see over here. These data points are precise, but obviously it is not accurate because it is very far away from the true value. So data points that are close are basically precise, and accurate is basically close to the true value. So just remember that your measuring tape and measuring rule, the accuracy is 0.1 cm. So when do I use measuring tape vs when do I use meter ruler? If the accuracy are both the same, why do I choose measuring tape over meter rule? The answer is very simple. As the name suggests, meter ruler means you can only measure up to 1 meter. So if I have a 2-meter object, instead of using my meter ruler to measure it, I should use my measuring tape instead. So another situation where we use measuring tape instead of meter ruler is when we are measuring a curved surface. So for example, if you want to measure the circumference of a tree, obviously we cannot use a meter ruler because we are unable to bend it. So measuring tape will be used instead. Okay, then now there's multiple errors when we are reading. The first error that's extremely common is actually called your parallax error. So parallax error basically means when you are reading it, you are not placing your eye vertically above the scale. So let's look at this. What happens if you put your eye at position 1? If we extrapolate this, our reading would actually be around 2.6. And if we are at position 2, which is not vertically above the scale, our reading, right, would actually be around 2.4 instead. So the only way that you should read correctly when you're reading a ruler is to actually look vertically above the scale, 90 degrees. And this will actually give you the most accurate reading. So to solve your parallax error, what you should do is to basically place your eye vertically above the mark of the scale when taking the reading. So n errors in this situation is basically when you start with a, okay, so your rulers usually will look something like this. You start with a 0, you place the object over here. N error is when your ruler is broken. So you have no idea where you're actually starting. So this error is actually not that common. The other common error, this is extremely important over here, is actually zero error. So what is zero error? Zero error is when you're actually placing the object that is not exactly on the zero mark of the scale. So a positive zero error, as the name suggests, is when you're placing the object that is slightly in front of the zero mark. And a negative zero error is when you're placing it behind the zero mark. So take note the difference between a positive error and a negative zero error. Okay, so this example over here is very simple. What is the accuracy of the instrument? They said over here it is a meter rule. And your content is important because you will have to remember that your meter rule is 0.1 cm accuracy. And then over here, for the part B, they're asking you which position should the eye of the observer be placed. And the answer for this is very simple. So obviously, this question, you have to identify, it is asking you parallax errors. So to reduce your parallax error or remove it, what you should do, right, is to actually view it vertically above. And the only answer for this is B. What is the length of the metal block? This is simple again. What we can do, right, is to first find the reading over here, which is 5.2 cm. And we can find the end reading over here, which is 7.3 cm. So if we know that this over here is 7.3 cm and the start reading is 5.2 cm, to find the length of this block over here, we simply take 7.3 minus 5.2, and this will give us the answer 2.1 cm. Okay, let's move on now. This one is all relatively simple. Okay, oops. Okay, so now let's move on to your external and internal calipers. So external calipers, as the name suggests, is basically measuring the external diameter of an object. So for example, over here, this external caliper can be used to measure the external circumference of this object here. This could be a PVC pipe. And if we want to measure the external diameter, we'll have to use the external caliper. So what you want to do is to basically tighten it up over here, shift it to a meter ruler, and then read it. Your internal caliper, as the name suggests, is to measure the internal diameter. So again, extend it out until it touches the sides of this object over here, and then just place it to a meter rule to measure. So this is relatively simple. So now let's go to our vernier caliper. So vernier caliper, this you guys should be familiar. I think set 2 probably covers this already. Your vernier caliper accuracy is actually 0.01 cm. So for digital vernier calipers, it is 0.001 cm instead. So take note if the question is asking you for manual vernier caliper or digital vernier caliper. So your vernier calipers over here, you have to be very familiar with the different types and components and their purposes. So first of all, you have to know your internal jaw and your external jaw. So your internal jaw and external jaw of a vernier caliper is basically the same as your internal caliper and external caliper. As the name suggests, internal jaw is basically used to measure the internal circumference or the internal length of an object. Your external jaw is basically used to measure the external circumference of an object. So your tail is actually the interesting one. Take note, your tail, right, is actually used to measure the depth of something. So if I want to measure the depth of, for example, a measuring cylinder, I will have to use the tail instead of your internal or external jaw. Okay, so now let's go to the fun part, the reading of a vernier caliper. So a reading of a vernier caliper is actually quite interesting. Your vernier caliper is split into 2 sections. You have your main scale over here and you have your vernier scale. So to read the vernier caliper is actually very simple. It is actually just a 3-step process. So let's go through this. The first step you want to identify is to first find where is your vernier scale. Usually your vernier scale is located at the bottom, and we will look at the 0 mark. So looking at the 0 mark over here, we can see that it's in between 6.3 and 6.4. So if it's in between 6.3 and 4, it means that it is 6.3 because your vernier scale is used to read the second decimal place. So we know that this first part is 6.3. The second step we want to do, right, is to identify the line that coincides between your main scale and your vernier scale. So what coincides basically means that it must be vertically straight. So if we zoom in over here, we can see that actually this line over here is perfectly straight. So I'll erase this so that you can see it again. So as you can see here, it's perfectly aligned. And this over here is actually 5 points away from the zero mark of the vernier scale. So what this means is that the number over here at your second decimal place will actually be 5. So your final answer, which is your third step, just write down 6.35. Always remember to include cm. So your vernier scale is basically used to read the second decimal place. So remember, I'll do a brief run through again. The first step is to identify where is your vernier scale and the 0 point. The second step is to identify where it's located. In this situation, it's between 6.3 and 6.4, so it's 6.3 something. The last step is for you to actually look at the point that coincides, that aligns. And in this situation, it's actually the fifth mark for the vernier scale. So your answer will be 6.35. For those who didn't understand, just do a quick run through again. You can rewind the video. Okay, so let's do some examples, or maybe not. Okay, let's do some examples. So again, always remember the three-step process. The first thing is to identify where is the vernier scale and the 0 point. And the vernier scale, obviously, in this situation is at the bottom, and the 0 point is somewhere in between 6.1 and 6.2. So if it is in between 6.1 and 6.2, we know definitely that the first two digits will be 6.1 something. And to identify what is at the second DP, we will actually have to look at the line that aligns between your main scale and your vernier scale. And in this situation, it is this line over here. So how many spacings is this line away from the zero mark of your vernier scale? 1, 2, 3, 4, and 5. So in this situation, we know our answer for part A will be 6.15. Okay, let's move on to part B. So part B is a slightly interesting question because part B actually doesn't give you a number over here. But what you should know immediately that this over here is actually 3.5 something. So how do I know? So this is 3.9, 3.8, 3.7, 3.6, 3.5.